Hey there, Russ here. Welcome back to the shop. Okay, we're gonna go into another. This is about my Ryobi, my Ryden power supply that I'm building. I use the RD6018W as my meter that I bought. If you remember, I put it in this box here. This is the Ryden meter right here. But I made my own box for this, and I put my own power supply setup in this, different than they had their setup. I have if you remember, I also showed you this a couple episodes ago. This is my 3-battery Ryobi battery hookup, where I can now hook it up, and if I want, I can take the switch and move it this way, and I'm getting 60 volts. They're hooked up in series. If I turn it this way, I'm getting 20 volts. Out here. So it's not a bad little unit to have in conjunction with this, because what I can do is I can now use this, and I'm going to put it on 60 for now. I can use this to power my meter. So I can run this thing off of an AC power outlet or DC power plug-in. So let me show you what I've got. We'll go over the meter here. I'll show you some of the niceties about it. But to begin with, these are my wires, and I have 2 hookups to hook up. I have my 110 volt here, and I haven't mounted this into here yet because I don't know how I'm going to mount this stationary on the panel yet. I'm still looking at my options on that, but eventually this will be just plugged in so I can just plug my cord into it. I store most of that stuff in here. And I'll go over everything, how it's all set up a little later on. Let me first show you how it works and how I can make it work for both an AC plug source or a DC power source, either one. So let's plug in this cord here to begin with. And I'm just going to plug it into an outlet. And then plug my plug in here. So when I turn this on, it now gives me 110 voltage in, which goes directly to my power inverter. This is a 24 volt DC power inverter. So that's why the meter will then run off of that 110 volts into the 24. So it's running off of 24 volts DC, getting its power source from here. So this is my one power source. If I want to go with just DC power, instead I can hook this one up. And for this one I use, where's my cable? Oh, there it is. So for this one, I just plug my Anderson cable in. And these plug into my battery pickup here, the positive and the negative banana plugs. I'm just doing this temporary to show you how this works. So right now we're getting 60 volts out of here. 60 volts is coming in. So if I turn this back around, too many wires. Okay, if we turn this back around, I want to raise that up. Let's raise that up a little bit. Is this too much? Oh, that'll work pretty good. That's one of the things I want to do with this. We'll go over that again. I want to make some stands on this that I can flip down and raise this up if I want to get a better angle on my unit. So this switch here tells me whether I want to, whatever my power source is. If I'm plugging into DC power, I would move the switch this way, and then I would be running off of the DC power, like so. And now, because I am hooked up to DC power, it powers up, and I'm showing 59.7 volts coming in. So my 3 batteries in series is giving me that 60 volts. If I want, let me turn it off. So I go back to the center, and it turns off, no power. And I'm going to switch the voltage from 60 to 20. Now when I turn it on to DC, it'll power up, And now it shows 19.67 volts. I know it's hard for you to see. You're going to take my word for that one. But on DC now, because of the way I have this set up. So I turn it off. Let it power down. I'm going to go back to 60 volts here. So now I have 60 volts if I go to my DC. And it powers up on there. So what about if I go to AC power? So let me go to neutral. Then I'm going to go to my AC power. And now it powers up. If I turn the switch off at the back here, you can see that the power then drops down and goes off. So the inverter is now off. So I can turn that on. And if I turn this to neutral, I now have both DC power and AC power coming in. I can do either one. The reason I wanted to go with a DC power input also on this unit is because I did buy the 24 volt inverter. So 24 volts is the maximum volts I have to work with on this power supply. It's basically a butt converter. So you have to have more power going in than what you're trying to pull out of it. So if I've got 20 volts going in, I can only pull about 1% less than the 20 volts, which would be 18 volts theoretically. And that's the most you'll get out of it, out of one Ryobi battery. On 60 volts, I'll get about 54, 55 volts, I believe, is about what I'll get off the meter coming outputting on my banana connectors here, which I control from the unit. So I can get up to 60 volts of input into my meter now by having both the DC and the AC outlet plug in. And I only had to buy, most of the time 24 volts is going to do okay for me. So I bought that for only around $20 as opposed to a 60 or 70 volt inverter would run closer to $100. Maybe a little less if you shop around hard enough at times. But you're going to spend close to $100. So it's quite a bit less by doing it this way. All of this other setup didn't cost me probably 10 or 15 bucks in attachments. And this is set up and it works perfectly, like I said, in both the AC mode. If I turn that on, if I go to AC, whoops, I turned it off, didn't I? And now it comes on, and I show an input of 24.49 volts. That's what the inverter is putting into the meter. If I want to draw it off of my Ryobi battery setup off of some DC source, whether it's a 12 volt battery or several batteries hooked in series, I can go to my DC current. I have to let it go off for a minute, let it power down. And now I'm showing 60 volts. And that's coming in. Because now I'm running off of the Ryobi batteries off a DC plug-in instead of off of my AC unit. So, I'm very happy with the way it turned out. There's some other things I want to do to it. I want to cut some holes in it because obviously the air circulation in there has to be set up. So I'm going to have some inlet holes and outlet holes strategically drilled on the box. And like I said, I also want to... that's what's holding me back. So, anyway, when it's not in use, I can just store all my components inside the box. That's why I built it oversized. This is so much better this way than the other. So, I'll get into the bells and whistles and what I'm going to be doing with this in a moment. Let's take a quick look at this wiring diagram bell first. So let me take and turn this way. Okay, we have to unplug that. And I think you can see that okay. So, what we have here, quite simply, is I have the switch right here. It's a double pole. Single throw, double pole, or whatever it is. I have two powers on it. The center is that goes to the load. So this one goes to the meter itself on this switch. And then on this one, when I push the switch over there, that goes to the DC power right here, this terminal. So this terminal is going to my positive on my power plug-in, my power pole. If I go the other way, now it's going to this angle, and it's pointing to this lead. This lead is going to the output of my inverter. So this is 24 volts coming off the inverter. When the inverter is turned on, I'll see 24 volts at this terminal. And then I switch between this terminal and this terminal. They're both DC volts. But this is, the source is a 24 volt source. And this one is anywhere from 6 to 70 volts if I want to plug a DC unit into here. Now I can go all the way to 70 volts. I have a DROC DC boost converter that goes up to 120 volts. So I can take this 60 volt, hook that up in between, and boost it all the way up to 70 if I want. And that thing has a 15 amp capability. So I can actually technically go all the way to 70 volts of DC current on this if I want to push 70 volts through my unit and test through here. So I can get all the way to what the test unit will do to its full capacity by having both the DC outlet and the AC outlet. And I don't need a super high power inverter in order to run tests for a 60 or 70 amp unit. I can just use my simple Ryobi batteries as my test power source. So this actually is pretty good, and it does save me some money, again, like I said, because I didn't have to buy one of those super high inverter that every time you turn it on, that thing ever goes bad, even if you're only doing it at 12 volts. If this thing goes bad, I can replace it 4 times before I paid for the other one, and I can still do a 60 or up to a 70 volt plug-in on this if I want. So that's kind of where all that is at. Let me show you the wiring here so that if you want, you can pause this here and get a close look at it. This is the wiring diagram as professionally drawn by me. Let me zoom in on it. Back out just a little. Can you see that okay? Yeah. Okay. So now you see, here's the power supply, the inverter. Here's the double throw switch, my DC input, and my AC input. The AC input has 3 wires coming in from the 110 voltage, line, neutral, and ground. And they hook up to the inverter at one side. Then next to that, you have 3 negative terminals and 3 positive terminals that are 24 volt from here. These 3 are really, they're just like a terminal block. So I took the negative from this plug-in and I plugged it in here also so that all my neutrals are all go to the same terminal block, which happens to be part of this inverter. As far as the positive, so your output on your positive here of the inverter, that goes to one side of the switch. The DC input here, she's bothering me. Give me a second here. There you go. Now go on. Go lay down. Go on. So the other positive from the DC plug-in goes to the other side of the switch. So I can, by screwing the switch one way or the other, I go to this power source or this power source. That's basically how the wiring works on this. That's way too close to look. Woo! So anyway, that's the way this thing really works. I'm very happy with the output of it. And like I said, when it's not being used, I can store most of my stuff inside here without any problem. And, whoop, there it is. So I can just store all these different pieces. And I'll probably find like this, I'll probably just find some way to hang it up on the lid when I open and close it. I also have my documentation is going to be attached to the lid. I'm going to make a little pouch for all of it to sit in. So all those papers that would go for any of this will be in here. Right now, this is the box from the power supply. There was nothing else with it except this. So this gives me enough information to have to do something with that if I need to. And that stuff is under here. So anyway, so I keep my documentation here also. There were some little pieces that came with the power supply, and I just put them in one of the little prescription bottles. As you know, I use these for everything now. And it has the temperature sensor in there, the extra fuses and different things like that that comes with it. That way I have all these parts for service this if I need to. So I store my 2 cords in here. I do want to I think I'm going to put a center pad back here, a small 2" by 2" pad or a 1" by 1" pad to raise it up about 1/2 inch or 3/4 of an inch. And then on the front, I'll put 2 more, one on each corner here. Then I'm going to put a little 2 turn pins here of longer pieces that will sit here like this. So if I want to tip the box up, I can tip it one way and it will stick down just so far. If I want to be able to adjust it, I would turn it to the other one and I could adjust it to where it's this height maximum, and I can actually adjust the height if I want to make it sit not quite so high. So by having this pivoting one, and that when it's in this position, it's not being used at all. It just sits flat on the surface. So I'm going to make a couple of pins for legs that go on here to be able to adjust the height as I want. So I think that's about it. I also have to drill some holes still. Now that I've got most of the electrical done and it's functioning, now I'm going to work on getting the air cooling going. Because right now, in order to use it, I just leave the lid open. And that is sufficient. But eventually, I like to drill some holes strategically. This is the input air for this unit. So I want to duct this off to the outside here. So when the lid is shut, air has to come in from the back and go in there rather than pulling air from inside. So when it exhausts out all the other vents, I'll have some other holes strategically put. So I haven't got that down 100% of how I'm going to airflow this. But the airflow is not going to be a critical thing about this unit. I don't think it'll ever really be super hot at any given point. And like I said, I have my 2 inputs back here. I'll put the other one probably up above this one for the DC plug-in. And this thing is pretty much what you see as a unit. So the way it works, I'm going to have some kind of mechanical fastener here, I think, eventually too. I don't know what I'm going to do. Maybe have a little turnbuckle or something that I'll do. I want to keep this area clean, and I'll probably put some pads on here so that most of the time when I store it, it'll store in this position here so it won't take up so much space on the shelf. And when I use it, I can turn it down like this, or I can even use it like this if I want to read it sideways. Or I can turn it down like this and adjust the height to get the best angle for reading this wherever I'm working. So that's my unit. It's coming along. I still have to sand it and finish it, but that'll probably be the last step. Right now, I'm going to work on getting the rest of the accessories going, figure out what I'm going to do about a latch, and then put some feet on this so that it raises it up and drill the holes. So this thing will then be pretty close to being done. And I think for a finish, I'm just going to wipe on boron linseed oil, 2 or 3 coats of that. And that should be enough to protect the outside of it. So that's it. This is my version of the RD60, the Ryden RD60 series. It's the 18 amps unit, and I think I'm very happy with how it come out. Now I am going to take this unit here. It's pretty arcade and pretty bulky. I'm going to turn this into a box about 1/3 this size that these things will just push down and plug into, and it'll have a plug-in on the side for both banana clip for putting a banana connector, and I'll also probably put a Anderson power pole connector. So I can use either of the connector when I'm using it. Then all I have to do is grab 3 batteries, plug it in, and now I have an instant 60-volt power pack. So that's about it. It doesn't do charging. It won't do anything like that. And like I said, it'll be a lot smaller than this thing is right now, because I was wanting to make sure it even worked up to now. And I will probably not use these for the battery plug-ins. I'll probably use these. I'll make my own, my shop-made ones, instead of using the factory ones to make this unit here. Because when I get done, I'll probably have like $6 or $8 wrapped up in this whole unit then, which would be more than a reasonable price for having a quick 60-volt power pack. Not bad. So I'll show you that when I get it done. But that's everything in a nutshell. Looks like I spent over 20 minutes here yakking away about this whole thing. I am happy. If you have any questions, any thoughts about how to change it. And yes, there was a comment I made about this knob being a little too obnoxious. And it probably is. But I had to have something. I found that in the drawer. I will probably replace it with whatever kind of latch I put on it, because I want to make something to stay closed. That way when I tip it up like this, it isn't going to pop open and stuff start falling out. So, and that's about it. Any questions, comments? Any thoughts? Anything else you want to talk about? Just leave it in the comments. I do read them all. If you learned something here, you like this video, hit that like button. It does let me know I'm doing the right thing. Most importantly, though, please come back again, because I'm nowhere near done. Thanks. And we got a lot more plans for these Ryobi batteries of things we're going to be doing. So stay tuned. And you'll see what else we're doing. Thanks. We'll see you guys again very soon.